Okay, so this one is the kinematics lesson on displacement time graph. Is the learning objectives of this set or lesson slides is to plot and interpret a displacement time graph. Okay, to apply and to understand what is the application of it. So some prior knowledge required. You need to know what is displacement and velocity of an object. You need to be able to know how to calculate gradient for a straight line graph. So displacement time graph is it actually does describe the displacement of the object with respect to time. In other words, it charts the displacement of object at different timings. So through displacement time graph, we can interpret it and deduce the velocity of the object. Okay, so first start with something simple, the displacement time of a stationary object. A stationary object will of course stay at its position when time passes. So of course in other words, velocity of the object is 0. Thus the displacement of the object would remain the same no matter how long the time passes. So some point to take note is that a stationary object doesn't mean that its displacement must be at 0. It can be actually anywhere. Okay, just to illustrate. Okay, using this, so the velocity is 0. The position can be actually anything. You can be at 5 meters. So let's just 5 meters, and yep. So this starting person is 5 meters, and we just start the time. And you notice that of course as time passes, it will just remain at 5 meters. So the displacement time graph actually charts where the object is at time passes. Okay, so well, you can say that the object is at -5 meters. Okay, so if you start this, what will happen is that it will just be at -5, and since it's not moving, it will just remain at -5. So as you can see, the displacement time graph of a stationary object is very simple. It's just a flat line. Okay, it will be a flat line at the starting displacement. So, and you note that a flat line, the gradient of the graph is of course a 0. Now, let's look at the displacement time graph of an object with uniform velocity. Means that the speed remains the same, so it's moving at a constant speed at all times. For example, an object moving at 2 meters per second means that for every 1 second it moves by 2 meters. So in this case, we assume that starting displacement is at 0 meters. You had the following displacement and time pass by. So when time equals 0, 0. When time equals to 1 second, it moves by 2 meters, so it's 2. And at time equals to 2, it moves by another 2, it's 4, 6, 8, 10, and so on and so forth. Okay, I plot it out in the I display in terms of the table format so that you understand that what does constant velocity means. So if you plot it to a displacement time graph, it should look like this. So at 0 is 0, at 1 second it is at 2, at 2 seconds it is at 4, at 3 seconds it's 6, and so on and so forth. So if you join the lines together, you notice that of course this is a straight line. And if you do the calculation of gradient of this graph, you have also the value of 2. Okay, yeah. So which incidentally is also the value of the velocity of the object. So generally we can conclude that the gradient of the displacement time graph is the velocity of the object. Okay, so let's just do a comparison. If you compare the graph of object of let's say 3 meters per second and 1 meters per second with 2 meters per second, so 3 meters per second of course is obviously faster. This 1 meter per second is actually slower. So let's look at the difference in terms of the gradient. So I want you to pay attention to the gradient of the different velocity. So if we do a plotting, this is the original 2 meters. If you plot 3 meters per second, you find that of course for 1 second it goes to 3, 2 seconds it goes to 6, and so on. So it should have this. And of course with faster speed, with the same time, it will travel further distance away at 15. After 5 seconds it will travel 15. Okay, and you find that for 1 meter per second is simple. After 5 seconds it will travel 5 meters. After 5 seconds it will travel 5 meters because it's 1 meter per second. So okay, I want to pay special attention to the graph, the gradient itself. You find that this is a steeper gradient as compared to this, and this is a gentler gradient. So that means that you can actually compare the velocity of the object visually by comparing the steepness of their displacement time graph. And you will find that the steeper the gradient, the faster the object. So if you see a very steep gradient, it is actually moving very fast. If you see a gentler gradient, it is actually moving slower. Okay, so you can do this visual or mental visualization. Of course, for velocity, it has a positive and negative sign. So right now we talked about negative velocity. So what does it mean? Okay, revision. Okay, recall that object has a negative velocity. It means that it's just traveling in. It doesn't mean that it's traveling slower. It means that it's traveling in the opposite direction compared to the positive direction. So generally, if we take positive direction to be right, then having a negative velocity means that the object is simply traveling left. So let's just do an example to help you to understand. If assuming that, let's say object is negative velocity of 2 meters, and let's just for discussion sake it is at 10 meters, starting displacement is at 10 meters, and traveling negative 2 meters per second means that for every 1 second it moves by negative 2. So what it means is that at 0 it's at 10. So after 1 second later you move by negative 2 means it's 8. Negative 2 it is 6. Negative 2 4 2, and this is actually supposed to be 0. Okay, so this is just to show you what happens. Okay, so the position starts at 10, and then the velocity is negative 2. So if we show the vector, actually this person is traveling towards this direction. So if we start the time, this is what's going to happen. Okay, so as you can observe, it's going towards left. Okay, this would be the graph. Okay, this would be the pattern. Starting at 10, 8, 6, 4, 2, 0. Okay, and this is the having a speed of negative 2. So for negative velocity, you find that actually the gradient of the displacement time graph is also negative. So that means that if you see a displacement time graph with a negative gradient, it means that it has a negative velocity. So it is, of course, it implies that it travels in the opposite direction as compared to the positive. And if you do a calculation of the gradient itself, it shows our negative value of negative 2. So again, the gradient of a displacement time graph is the velocity of the object. So same thing, we do a comparison. So if you do a comparison between negative 2, negative 1, negative 2, negative 3, the steepness of the gradient would indicate that it is the velocity. Okay, so the steeper the gradient, the faster the velocity. Okay, and of course the negative sign only indicates that the objects are traveling left. So this is what's the original negative 2, and for negative 1 it is 10 meters, 9, 8, 7, 6, 5. And for 3 meters is of course a negative 3 meters per second. It is 7, 4, and subtract 3, negative 1, negative 2, and negative 5. Okay, so you find that of course it travels faster. Okay, again having the steeper gradient actually tells you that it is actually traveling faster, just only that it's traveling in the opposite direction. So right now, the interpretation of displacement time graph, okay, by understanding the basic interpretation of the displacement time graph, we can easily visualize the motion of object at different time by just breaking that up into different sections. So you break this up into 1 section, 2 section, 3 section. So this is just a practice question for you. So if we look by looking at this graph and understanding whatever that we've gone through, when is the object stationary and when did the object move left, and are you able to calculate its velocity, and when did the object move right and were you able to calculate its velocity.